So why don't we go ahead and get started with Liz. So without further ado, we'll switch over. I know a lot of people have been adopting SLOs. SLOs are super hot. So Liz was on the line, and hopefully Danyel will join us later, but they're going to be talking about the pitfalls that they've experienced and hopefully you can avoid when you're implementing SLOs.
Hello, everyone. I'm Liz Fong-Jones, and I'm a principal developer advocate at Honeycomb. And my partner in crime, who is working out AV issues, because conference AV issues, they happen online as well as in real life. My partner, Danyel Fisher, in this presentation is a principal design researcher also at Honeycomb. So we wanted to share a little bit about our experience engineering for large scales and how that wound up working out for us as we encountered some scaling issues. So this is fine, right? Like, this is a perfectly normal day at the office. Oh, hey, wait a second. What happened between 1500 and 1800? Well, as they say in the movies, enhance. That doesn't look so good now, does it? That is, from 1550, our traffic steadily declined until we hit 0, and then we served no queries for about 9 minutes before our service came back to life. What happened? And was that a big deal or not? So the theme of today's talk is thinking about how broken is too broken, and what do we do when things break? And how do we measure whether or not it's an emergency? So we were down for about 12 minutes in total. Danyel might say, oh, 12 minutes isn't very long. That's 2 years in internet time, right? Like that's horrible, right? Like 12 minutes, good times, bad times? Well, it really depends. And a lot of how we resolve these disputes relate to this idea of thinking about what our reliability requirement is. Should we be moving faster? Should we be moving slower? And for this, we have a wonderful, wonderful tool that potentially can help us get to this knowledge and understanding between management, engineering, and our customers of what reliable enough means for our services and how broken too broken is. So how do we actually measure this? What are some of the concrete building blocks that we might need in order to figure this out? First of all, we need a telemetry system that can produce events that measure the quality of service that our users are experiencing. Secondly, we need a mechanism for describing these events as eligible to be considered or things that we don't care about, things that are like botnet traffic, automated health checks from your load balancers, those things we want to discard. We just really want to focus on user experience. And then finally, we describe some of them as meeting user requirements or not meeting user requirements. So this is the idea of the service level indicator. Eligible, is it actually an HTTP event, or is it like some database called down in our stack? And good, was it served with HTTP status 200, and was it served in under 500 milliseconds? You saw the last presenter talk about latency, right? Like the way that we let latency not sneak up on us is that we set stringent criteria for what makes for a fast enough user experience. And then the overall quality of service that we measure is the percentage of good events divided by the percentage of eligible events. So the service level objective sets our quality ratio over a period of time, like months, that we can use to decide what our user requirements are and are we meeting them. And finally, our error budget measures the number of bad events that we're allowed to have over that same time span. It's 1 minus our SLO. And whatever's left over, we can use to deploy faster. We can use to do some chancy chaos engineered experiments. Or we can potentially say, you know what, actually, our customers are really, really excited and telling us they like this higher level of service. Let's try to maintain it over the longer term. So what are Honeycomb's SLOs? I've given you an idea in the abstract of what an SLO is. Well, we intend almost all of the time to store incoming user telemetry. We're a service that ingests your telemetry. So 99.99% of the time, if you send us an event, we want to ingest it. And most of the time, we want to have our dashboards load fast enough. And a majority of the time is good enough for any arbitrary user query. That's kind of where we set our bars, because we only have one chance to ingest that telemetry. And if we drop it, it's gone forever. So that corresponds to roughly out of a month, if you had 100% downtime, you could have 4.3 minutes of 100% downtime for a period of a month, and you would meet a 4 nines SLO, 45 minutes for a 3 nines SLO, and a couple of hours for a 2 nines SLO. So how bad was this outage actually? Well, This is the amount of user telemetry that was coming into our system, user data throughput, which means the 4 nines SLO applies to it. We should have no more than 4.3 down minutes per month. We blew through 3 months of budget in 12 minutes. Not good. So how did this happen? Well, we dropped some customer data. We rolled back the bad release. We communicated to our customers and we said, we need to halt deploys until we can implement some mitigations to prevent a bad deploy from causing this ever again. How? Well, we had checked in code that didn't build. It had a syntax error. Our continuous integration would have caught it, except for the fact that it was in experimental state and was passing a return status of, oh, everything's fine, return status 0, no matter what, even if it didn't build. And our scripts didn't check to see whether there were actually binaries in the package that they were deploying. Oops. And there was no health check and no rollback. So there was no mechanism for us to automatically detect that the release was bad and revert back to a known good release. So we fixed it by stopping writing new features. We didn't want to add on additional instability when we had something that we knew was not stable. And we prioritized the stability of our system until we were sure that we had mitigated the principal risks and the factors that led to and contributed to this outage. So SLOs were a really powerful tool for us to characterize what went wrong, how badly it went wrong, and how to prioritize repairing things. So this talk is going to talk about how we actually implemented SLOs in our organization and what we learned about trying to make them accessible to people other than us and people other than Google. So it is true, the concept of SLOs was popularized first at Google, and it came from this idea of let's measure the quality of our service and let's use that as an engineering and business driver. And this is the practice of site reliability engineering. Highly recommend these 2 books. But it turns out that despite saying for years that SLOs are magical, not everyone has Google's tooling. And the practice of doing SLOs at Google is uneven, I would say. Some teams do a better job than other teams. And even if you have an SLO at Google, it's not necessarily used directly to tie into helping you debug your production outages. It might just be a quarterly reporting tool. So we thought, we write an observability tool. Surely there's got to be a better way. So we decided we were going to try out this tooling on ourselves. So this talk is a mixture of 3 things. How do you express an SLO? How do you view and report on it? Secondly, how do you actually debug an SLO? How do you know when it's failing? And thirdly, how did we generalize this onto other people? So this first section, we're going to talk a little bit about kind of how we model the behavior of an SLO. How do we actually visualize it in an intuitive sense that makes sense to people who are developing applications? So in order to understand your SLO, you have to be able to understand, when did this burn down start happening? When did I start burning through my error budget faster than I intended? I need to be able to understand, why is it burning and how can I remediate it as quickly as possible? So there are a couple of different ways that you can phrase a service level indicator. The first way of phrasing a service level indicator is on an event-by-event basis. For instance, saying how many user-facing events had a duration of less than 500 milliseconds, where you're just counting each event as true, false, or null. The second way is time-based. How many 15-minute periods had a P99 that was less than a certain duration, for instance, 50 milliseconds, where for each 15-minute time period window, we generate a statistic about it and mark that time period as good or bad. And after that, we can aggregate all of these individual data points and say, this is the number of good data points divided by the number of bad data points, and here's where over my history I incurred those. For instance, if I have 1 million events that I saw, and I saw that a certain percentage of them are expected to succeed, that means that, for instance, if I have a 99.9% SLO, I can allow 1,000 of them to fail. If I've seen about 420 of them out of 1,000, right, that have failed, that means that I've only spent 42% of my error budget, and I have 57% of my error budget left, roughly. And then we can also think about, how have we done over each rolling window? For instance, the window that started yesterday going back 30 days, right, that I've achieved a certain level of compliance. But if I go back, a month ago and say, what did the month before a month ago, right? So 2 months ago to 1 month ago, what did that look like? What was my overall reliability over that window? So those are both really helpful views, in that the first view shows you where did you spend your budget, how much do you have left right now? And the second one says, am I actually realistically achieving my error budget or not over this longer window? So this is an actual SLO that pertains to Honeycomb. We think that Honeycomb pages should load fast enough, or else we have a problem and we need to debug it. Conversely, this one is a little bit more interesting, right? Like this one is one that concretely failed due to a few blips that resulted in each successive case burning a significant chunk of our error budget. Not so great. But we also need an additional piece of information, which is figuring out where is that extra slowness or error rate coming from. So here, for instance, we can see that we have an error budget here that we've spent about 42% of the error budget, as I was detailing earlier. So we're still meeting our SLO. But in particular, we've got this little area here, right? Like this summary that says that a lot of this error budget being spent is due to being too slow, right? It's all of the points that are above this line. And then you can also see that there's a smattering of these fast errors that happen relatively quickly. For instance, if we just reject something out of hand saying, oh, this is malformed. So those are two different categories of error that we can see by visualizing the duration of the failing or succeeding event. Here's another example.
What happens if things drop a lot? Cool, it worked. But what happens if things drop a whole lot further?
Well, then we need to understand not what's happening at steady state, but instead what's happening over this particular moment of like the past day. So in this case,
so for example, in this chart, you can see that we were actually burning at a pretty steady rate and feeling pretty good about the world until very suddenly, somewhere around February 13th, we had a series of interval outages or failures that ran for periods, eventually dropping us far below what we expected by over 200%. In fact, when you look to the right at our historical compliance chart, you see that that was bad enough to have, you see that between that and some earlier incidents, that was bad enough to have pulled us down and kept dragging the numbers down.
So in this case, this was a series of very fast errors that were all erroring, but within a few milliseconds. So these are useful realizations because they can help you dig into what's happening with the underlying problem. But in order to dig further and understand the contributing factors, rather than just give you some examples of queries that are a little bit too slow, we need high-dimensional, high-cardinality data of the kind that you might collect in an observability system. Stuff like this, things like their HTTP response status code, the error messages, fields from the request, like which user IPs, and even things like someone's individual email address, which data set, or potentially which customer ID they have, and so on and so forth. So these are helpful things to kind of understand, out of the proportion of things that succeeded versus failed, which dimensions are overrepresented, which values of those dimensions are overrepresented and statistically different from the good case. So in this case, we can clearly see that it's two specific users and from two different customers that are specifically causing this outage, or impacted by this outage, we should say. And in fact, we can say that one of these is could not find team because their team had been renamed or deleted. This is interesting, right? This gives us a much better clue as to where in our system we should be debugging.
Now, once we'd built this first interface, we started distributing it to our team. And, there was those great first moments where you'd look at the SLO and understand what was happening. But we also started getting pretty rich feedback. Amongst others, people saying that they'd like to actually drive their alerts off it. They didn't have something to drive them back in, and therefore they weren't actually seeing why it would be useful. So that brought us to the next piece of our system. We need to work on some alerts.
So this brings us to the idea of not just using it as a reactive tool of, oh crap, I looked at my SLO and it's already burned. Where did that come from? But instead, how can we prevent ourselves from going out of budget before we actually burn through that entire budget? Another way to think about it is, when will I fail? At what point in the future will I burn through my entire error budget if things continue as they are? And it might be fine for me to have burnt through my error budget 60 days from now if my error budget only covers 30 days. But at the same time, we don't want to run out of error budget in a matter of hours or a couple of days. That would be bad. So we can kind of think about this idea of, if it's going to take more than 24 hours for it to run out, we can wait until the morning. We don't have to wake someone up. But if we're going to run out within minutes or hours, we need to get all hands on deck. So this is a way of historically projecting the historical value and looking forward to see where will that error budget burn down curve be some hours or days from now. So we need to think about.
So the way that we
go ahead, Danyel.
So the way that we carry this out is actually through a completely simple extrapolation. We're just linearly interpolating backwards from how things have been recently to a predicted exhaustion point. So if we're, for example, want to understand how we'll look in 24 hours, we can simply look at the last 6 and, assume that the next 24 will look something like that. If we're looking at 4 hours, we'll look at a much shorter baseline, because it's really important that we be able to be fairly responsive to what's going on quickly. This extrapolation, though, does allow us to figure out whether we're going to make it over time or not, and therefore figure out how soon we're going to burn down.
There are more sophisticated methods that could take into account seasonality, but in our view, you have the historical data, you may as well use it, and it's probably good enough for prediction purposes. So how we actually do this is we run that query of how many good events and bad events happen over a 30-day window at a reasonably short enough resolution, and then we run it over and over in order to calculate the number of good events and bad events and extrapolate that forward so that we can alert you within a couple minutes of things turning sour so that you can respond in time.
I see absolutely nothing whatsoever that can go wrong with running a 30-day query every minute. Can you?
Well, maybe there might be a problem. Oh, hey, look, what's that? That's our AWS bill. Wait a second. That is about $10,000 of AWS spend in 2 days in July of this year. I think the bean counters might have a problem with that. Danyel, back to the drawing board.
So we did end up having to sit down and work out some cache work, and of course, that's the kind of thing that you might have to expect. Really, I think it's really a lesson that premature optimization may be the root of all evil, but there are possibly even worse things than that. We've learned a couple of useful lessons, though, from the process of building out SLOs. For example, volume turns out to be really important. When you're dealing with a couple of 9s, it actually turns out to be scale invariant to the number of 9s and more to the number of bad events that your SLO can tolerate. And you need to be able to tolerate dozens, because 1 or 2 bad events could cause your SLOs to start flapping, and that's not very interesting. That should just go back to classic alerts.
Yeah, that goes back to the bad old days when we had, oh my goodness, the disk is above 90.01%, 90.01%. I'm shocked and horrified. Or we had one single bad query. So we need to have some kind of notion of tolerance of at least a couple of things blip in order to cause you to react. But there's another element of this,
which was the notion of fault. It turns out that when we were first writing our system, it wasn't too important to our developers sometimes whether they returned a 400 or a 500, which error code they precisely used to mark the notion of error. As soon as that started burning SLO, much more interesting. When we were getting error budgets because a user was sending us crappy data, people got very interested in suddenly tracking this sort of thing a little more carefully. And so you will now see sprinkled throughout our code a brand new dimension, the our fault and their fault fields, trying to track down precisely when we need to count things into our SLOs and when we don't.
It turns out that if someone has an expired trial, you probably don't want to count that as a systematic bug in our systems. We also had a couple of positive things that we realized, that you can use SLOs to detect, even if something is within SLO, if you see one or two customers that are particularly badly impacted by something, you can, during business hours, look to see whether the errors are sprinkled out evenly across all of your customers, or whether you need to contact individual customers to say, hey, you're doing something that might be causing suboptimal results. Here's how to avoid it. So blackouts.
In the last talk, we heard a reminder that brownouts are kind of the place where you want to be looking as your next stage after beginning to solve incidents. And in fact, one of the things that we've found is that blackouts are easy. Almost any alerting system in the world will very happily tell you, yes, something's gone horribly wrong. Brownouts are more interesting. And Liz has a very personal story about this. So
I happened to be at the what turns out to be the very last Velocity in Berlin last year. And I got a Slack ping that was not yet a full alert, but that was related to this feature we were working on, and said, hey, your ALBs think that they're timing out or erroring talking to your ingest backends. And I was like, this is interesting. So it went off and I was like, this is experimental code. Maybe it's just a blip, but I'll have a look at the SLO and hey, look, it says that 1.5% of our queries are actually failing. This might be a real issue. Well, okay, I've given it a couple of hours. It doesn't seem to be going away. It might be AWS's fault. The SLO goes off again and says, hey, you still have a problem. And I started actually waking people up. And I started actually waking up very, very tired people on the US Pacific coast saying like, hey, our SLO, I think that it's actually not a false alarm. I think there might be something going on. And it turns out that we were having hosts disappear off of our service. They are just disappearing from serving. And an observant engineer said, why is the process uptime dropping to 0 over and over? It's out of memory. We aren't alerting on that crash. And neither were our black box probes that were saying, oh, we had one bad probe, but it was fine afterwards. We don't alert on random blips. So it kind of took that SLO to really reveal to us that we had a serious problem, and it was a brownout impacting 1.5% of our users for 20 minutes at a time, every couple of hours. Turns out memory leaks have a very particular pattern. It looks something like this, where you have that curve of the memory leak driving up your amount of RAM in usage until it all goes back down to 0. And then it resets and resets and resets. Not good times. So this was how much of our error budget we spent.
So yes, this one incident burned through 600% of error budget. And you can even see in the timeline the very specific moments when the entire fleet ran out of memory together and failed together, which is what set off these alerts for us.
So what did we learn from this? Well, we learned that maybe our pre-existing alerts were not as helpful as we thought they were, and instead that our SLO burn alerts were much more helpful than we had initially given them credit for. So this gave us a lot of incentives to turn those SLOs over to being paging status and to reduce our dependence on other kinds of alerts. So we have a lot more SLOs that measure the quality of service that we're delivering to our users and enable us to really ensure that all of our alarms are actionable and that we're detecting both degradations in service in terms of availability as well as latency, in addition to just being able to detect full-on blackouts. So here's what Danyel and I want to tell you in conclusion.
That SLOs in the end allowed us to characterize what was going wrong, how badly it went wrong, and how to prioritize repair. Doing that allowed us to really speak to what our systems were doing and prioritize where our efforts were going.
And that prioritization piece is really, really key, because there are umpteen different things that you could be working on as a reliability project in your organization. But this really helps you make the business case to say, this is what we ought to be fixing, this is why we ought to be fixing it, and this is why we oughtn't to be prioritizing these other things. Because everything can cleanly be expressed in terms of your service level objective and whether or not you're on target to meet that SLO.
The reason we've put together this talk is because we'd like you to know that you can do this too. None of the tools that we're showing today are particularly sophisticated. And I mean, I'm even seeing in the chat people going, come on, guys, you can implement caching better than that. That's not precisely how that was phrased. the point is, you can do this too, and you can avoid our mistakes. The opportunity to, divide success by possibilities is a math that we all can do, and that can make all of our systems more robust and a little bit stronger.
Yeah, it's kind of just all of these little realizations that we had when we started applying these techniques that, people hadn't necessarily experimented with a lot because they were just trying to do things rigorously by the Google book. It turns out there are a couple of learnings that go beyond the things in the Google book. And hopefully from us giving this talk, you can learn to apply it within your own tooling. You definitely don't have to be Honeycomb. You don't have to be Google. You just kind of have to have that mental shift towards treating SLOs as kind of good event, bad event, and doing that error budget prediction into the future in order to really get a grip on your alert fatigue.
We're pretty much running out of time, but I'm seeing a ton of really good questions in the Q&A. So I'm going to encourage you to hop over into QA, Danyel and Liz, to ask us these. We'll both be hanging out there for a bit to answer questions and continue this conversation. We'd also encourage you to, scan the links, hit us up on Twitter and email and talk to us and have all the other conversations.
Yeah, and we'll also share the results of the polls that the production team put up during this. And that way you can learn kind of how much company you're in terms of how much you knew about SLOs before and after the talk. And if you'd like to have access to these slides before the mass email, you can go to honey.co/Danyel or honey.co/Liz, and we will send you an advanced copy of those slides. Awesome. Thanks for hearing us out, and sorry about the technical difficulties.
Thank you so much, Liz and Danyel. We do have a little bit of buffer time. Happy to have you if you're still on the line. There's one question in particular that I love, and it's getting a ton of upvotes from Sophia Russell, who asks, how do you handle implementing SLOs from scratch with reasonable defaults? With a follow-up question of, is there even such a thing as reasonable defaults?
Reasonable defaults. It depends upon your user requirements. I think that you definitely will want to measure availability and latency as a property of your SLO, right? To make sure that you are measuring error codes, that you're measuring latency. I think the number of nines is something that depends upon, are you operating a 911 service or are you operating a e-commerce site, right? But I would say don't aim for too many nines if you don't have to, right? So, no more than 4 nines, probably something more like 3 nines to start with, unless you're operating a medical service. And I think that overall, for error budget burn down, I think 4 hours is a good stick in the mud to say for paging alert. I would say 1 day or 2 days is a good stick in the mud for a ticket. And then I think overall, kind of in terms of that measurement piece, right? Pick sensible defaults for latency, right? User interactive latency. We know people get grumpy when sites take visibly longer than about 150 to 200 milliseconds to load.
Great advice right there. So as Liz had already mentioned, they're going to be in Slack, so you can go ahead and visit them on the QA Danyel-and-Liz. So slightly different from our other channels, which are first and last name. We didn't want to get it too long, but we've got both of them in that channel. Thanks again to both of you for being amazing and just rolling with those audio issues. Truly, as this conference is about reliability and resilience, that is such a great sign of resiliency on your
redundant speakers. Each one of us could give it on our own.
Awesome.